Good morning, everyone. My name is Town Planner Shahruniza bin Samsudin. I'm from Department of Town and County Planning under Ministry of Local Government in Malaysia. So together with me today is Town Planner Wan Andri Wan Mahmud and also Town Planner Muhammad Ikhwan bin Saadun. So I'm pleased to be here at FOSS4G Auckland among professionals and innovators who share a passion for open geospatial technologies. Today I will share our journey in developing iPlan Malaysia Integrated Planning Land Use Information System, a national scale GIS platform that consolidates, standardizes and share land use data for better spatial planning and decision making. So through this talk, I will take you through iPlan objective, architecture, integration, process and lesson learned along the way. So I will share the topic today about empowering urban planning with open geospatial technologies, the iPlan experience in Malaysia. So here's what I will cover today. We will begin with an introduction to iPlan. Then move to its objective, data workflow, and system architecture. After that, I will highlight how iPlan integrate with other systems, explore its key application, discuss user adoption, and finally share challenges, lessons learned, and recognitions. iPlan was launched in 2016 to solve a major problem, fragmented and inconsistent land use data across Malaysia. Before iPlan, every local authority produced their own GIS database, often in different format and standards. So this made it very hard to combine or analyze information for regional or national planning. So to overcome this, Plan Malaysia developed iPlan as a centralized web-GIS platform for Peninsular Malaysia and the Federal Territory of Labuan. The platform now serves as the main reference for land use planning at the national level. iPlan enables us to visualize three key layers of land use, each serving a critical role in the planning process. First, existing land use. Next. This layer represent. Boleh kawan? Okay. This layer represent the current land use activities observed on the ground at the time the data was captured or surveyed. And number two, committed land use. This layer reflect land use commitment based on planning permission plans submitted by developers or landowners to the local authority. Zoning land use, this is the future land use zoning as outlined in the gazetted local plan. Each of these layers provide essential information for urban planning and national development, giving planners and comprehensive views on what currently exists, what have been approved for development, and what is planned for future. So the system bring together data from 103 local authorities in Malaysia, 11 state and 3 federal territories, covering 13.18 million hectares of land. iPlan was designed with three main objectives. First is standardization of data to unify land use information under a consistent classification system used by all planning authorities. Number two is integration and accessibility to create a single outline platform where planners and policymakers can access updated, verify and use information. So the last one is decision support to promote evidence-based planning where data support real-world policy decision. Keeping I-plan accurate require a structured data updating workflow. So data start at the local level, where local authorities update land use information using GIS tools. Next, the state planning department review and verify the data. Finally, plan measure, our department, consolidates and validate everything at the national level. So this slide show data updating workflow where all data set are refreshed existing 6 months through this structure update cycle. We have been able to maintain both the reliability of our data and overall sustainability of the I-plan system. Without accurate and up-to-date data, even the most advanced system cannot deliver meaningful results. So our data collection process draw 3 primary sources. First, very important, cadastral data from the Malaysian Survey Department. And number 2, land use information from planning permission plan and certificates of completion and CCC from the every local authority in Malaysia. And the last one is gazetted local plans provided by state government and local authorities. In addition, we also incorporate supporting land use data set from various government agencies to further enrich and validate our information. Once collected, all these input are transformed into GIS-ready data set following a standardized data structure and format. To process data is then verified and validated by stakeholders at both local and state level to ensure accuracy and consistency. Finally, the standardized and validated data sets are uploaded and published in the I-plan system, making them accessible to a wide range of users, particularly government agency, private sectors organization, and general public. Ladies and gentlemen, I-plan architecture is built for scalability and reliability, consisting of 3 main layers. First, data server manages more than 10 million of land use polygons and attribute tables. Number 2, GIS server handles spatial analysis, rendering, and processing using open standards such as WMS and WFS. So the third one is web server, hosts the web interface, allowing users to interact with map in real time. This architecture enables I-plan to deliver high-performance mapping services while maintaining flexibility to integrate future technologies. Integration is one of I-plan's strongest component. The system connects with PROMIS, Malaysia National Planning Monitoring System, to cross-reference land use data with project implementation data. It also shares data with other national agencies via standard OGC protocols, supporting interoperability across ministry. So this integration ensures that planning decisions are based on consistent, verified spatial data and promotes collaboration between government sectors, a key element of Malaysia's National Geospatial Data Infrastructure Initiative. Let's look at what I-plan can do. The platform includes several powerful models. First, the interactive Map Explorer lets users overlay different land use layers for analysis. Number 2, the thematic search tools allow filtering by land use category, for instance, identifying industrial and residential zone. Third, the multi-view panel provides side-by-side comparison between existing, committed, and zoning land use. And the dashboard module also summarizes data for each state and local authority, showing metrics such as land use composition, development intensity, or policy compliance. And the last one, the web interface, is built using Google Map API and open source libraries like OSM, making it lightweight, responsive, and easily accessible even with limited bandwidth. So for this system application, I would like to invite Mr. Town Planner Muhammad Ikhwan to present the detail. Please, Mr. Ikhwan.
Hi everyone, I'm Ikhwan. So right now I'm showing to all of you some of the video clip about how our system is work, and it's about the main features of the iPlan, which is the interactive mapping module. So I just click some on the video. Okay, in iPlan we have developed our system so that it can be easily used by our various background of users. For instance, in this clip video, it demonstrates how we can open the interactive mapping in multi-view panel, so that we can call different type of data or the base map in a specific location, so that we can get different information at the same time and at the same location with a synchronization location through this tracking panel. So for instance, here at the top left, we are opening the land use data in Malaysia. So you can see there are so many colors. The land use data, it consists of information of the land use data in Malaysia. And then at the other one, the second panel at the top right, I'm opening another set of data, which is a terrestrial data, which we get from the Malaysian Survey Department, so that we can compare different information. While at the bottom, I'm opening the different base map. This is imagery, and another one is the image. So at this point, we can simultaneously control the map and a single location with a different type of information at one time. And besides that, we also have a feature of the street, Google Street features in our platform, so that we can open or refer to the Google Street to get a clear information on the site or on the ground within a single platform in our system. Okay. Then lastly, we can also share, or we can also pin a specific location in our interactive map in our system, and we can share this location if we need to define further this information to others running or video. Then we can just open the pin location coordinate, and we can just share whether we can share with WhatsApp platform or so it's all more or less about the system or the interactive mapping module in the iPad, where it can help the user to get more information through our iPlan, especially regarding the land use information data. So I think I'm handing over to my okay.
Okay, thank you, Town Planner Muhammad Ikhwan. So, since its iPlan rollout, iPlan has gained strong tractions among users nationwide. From November to 2024 until October 2025, we recorded 117,806 users which in total, since it was developed for the last 10 years ago, we have recorded about 3.2 million users representing mixed planners, researchers, students, and policymakers. So this growing users base shows that iPlan is now more than government database. It has evolved into a national geospatial knowledge platform, promoting open access to authoritative land use information, fostering collaboration across different sectors. So building a national GIS system of this scale came with challenges. So we identify 5 key areas, very important. First is management support. Ensuring leadership buy-in is crucial for long-term sustainability. Number 2 is financial resources. For example, hardware, software, and maintenance require continuous investment. Number 3 is skill and capacity. GIS expertise is still developing. We invested heavily in training planners and analysts. Number 4, ICT infrastructure is a reliable infrastructure, is a must for the system to serve better. Number 5, data interoperability. Different data standards made integration very difficult. Adapting standardized data throughout each of its sources resolve many issues. So the last one is operating the system based on the open source platform is quite challenging, especially in terms of technical support within the organizations. So however, until today, we managed to overcome those issues with a proper planning and implementation. The greatest lesson we learned is that technology alone is not enough. Effective governance, teamwork, and continuous capacity building are just as important. Our collective effort has been recognized nationally and internationally. iPlan received the Gold Award for Sustainable Development Innovation at the Malaysian Technology Expo 2021 and the Silver Award for Planning Service Excellence at the Malaysian Institute of Planners Excellence Awards 2022. This award affirms that open geospatial system can drive tangible improvement in public sector innovation and sustainable development. So to conclude, let me summarize 5 key takeaways from our iPlan experience. iPlan represents Malaysia's shift towards data-driven and transparent spatial governance. Number 2, the project shows how open geospatial tools can enhance coordination and evidence-based planning. Number 3, sustainable GIS success depend not just on technology but also on skill, people, and inter-agency collaboration. Number 5, by consolidating millions of polygons into one platform, iPlan improve data reliability and accessibility, reducing the application of effort. And most importantly, iPlan prove that open data and shared geospatial infrastructure can transform national planning into more connected, efficient, and informed process. So thank you for your attention. Thank you. That's my presentation.
Thank you, Shaul. And does anyone have questions? Yeah.
No problem.
Thank you very much. Very interesting presentation.
Yeah, thank you.
I have a question about your way of working with those open source technologies. Did you have a team of developers inside your organization, or you worked with service providers? How did you manage to put together the components using different open source technologies? Thank you.
Yeah. Thank you. Very good question. Actually, we 3 of us under National Land Use Information Division at my department. So we work on one team, and also we collaborate with multi-agency, technical agency, and also vendor. We get the expertise from the IT consultant and also from our expertise. So with that, we can collaborate and produce the more and good product to produce the airplane system, integrated land use information system. That's
Is that is that hosted in your environment now, or is it hosted by vendors externally?
yeah.
Well, actually, our system is hosted at the National Malaysian Data Center on cloud. So our system is it's not in prem, but on the data center, the Malaysian Public Service Data Center. Right.
Under digital, under national digital platform. Yeah. Okay.
Hi there, Mika from Philippines. So we're very close, and I'm very familiar with.
Yeah.
And we have a very big problem with information like this.
Yeah.
How is the case in remote areas in Malaysia? Because the one you shared, it's very urban, street level, it's nice, things like that. So if there's no data, or are the towns, the remote or rural towns in Malaysia are able to satisfy the requirements or standards?
Yeah. Okay.
Okay, thank you. Actually, the main important in this system is not the system itself. It's the data updating framework structure. So, as we showed before, our framework of data updating, we collaborate with different level in the Malaysian, at the national level, the state level, and the local level. So we are work together to update the data. So regarding of your question about the rural information of the land use information, we get it from the first is from the local authority, because they know better what the land use activity inside their area. Then we also cross-check with the others agencies, for instance the agriculture department, because if you see, we get information at the urban area, the land use urban is from the planning permission plan. It's a plan on the paper, but we also have a problem sometimes when we want to update something that is not in the paper, on the paper. For example, the agriculture activities that change rapidly without we are knowing they change the type of activities, for instance from the old palm plantation to other crops. Then we need collaboration, or we need assistance from the local level for them to update to us, and then we will update our data. So at the end of the day, the most important thing is the updating structure framework. Without this process, our system is nothing. Okay.
So let me add on a little bit information. Actually, we have the mechanism, at the local level, or state level, and also federal level. We have the committee team, to update the data and verify the data. So in the local level, we have so many committee, like for example, forestry department. In the district level, fisheries department, town planning at the local level. So with that committee, we discuss together, update the data every 1 year, two times in a year. So we uploading the data in the iPlan system. Okay. This is my friend. We have
Last
okay. Last question.
I promise. Yeah. Last one. From what I could see, the platform is to bring the data together and govern the data and update and all of that. use it for development applications. Let's say when someone wants to build a new building in the middle of the city or somewhere, do you take those submissions through the iPlan, or they come separately, and then the data that results from that development application is then updated by manually?
Ramah jawab.
Yes, we update the data from the, like I said before, technical planning permission plan or the building plan. So we get those information from the local authority and the state level authority, and we convert into GIS ready data and we publish into our system. Okay. Sorry?
Okay.
Okay.
Yes, thank you, Shaul and Mohammed, for the great presentation.
Okay. Thank you very much. Yeah.